Section 7.6 is on common logarithms. A common logarithm is a base 10 logarithm. So if we said log base 10 of x, we can just drop the 10 and just write log of x. So in other words, if there's no base here, it's assumed that it's a base 10 logarithm or a common log. And remember, x has to be greater than 0. So first example is, well, actually this is really cool. Because these are common logs, there's actually a log button on your calculator that we can use to evaluate certain values. So first one says use a calculator to evaluate log of 0.5, and that's a base 10 log, rounded to the nearest 10,000ths, and that is 4 numbers to the right of the decimal point. So let me show you here on the calculator how we're going to do that. Okay, so right here is the log button, so I just push log and then 0.5 and hit enter, and there's my value, and it says rounded to the nearest 10,000, so that's 4 digits, so that's going to be a negative 0.3010. So that's approximately equal to negative 0.3010. I guess I should write log of 0.5. Okay, so really straightforward. Just use that log button on your calculator. Okay. Some equations and inequalities can be solved by taking the log of each side. So for example, solve 6 to the x equals 42. Now I have no idea what power I would have to raise 6 to get it to be 42, but I can use logarithms to do this. So I'm going to write log 6 to the x, and remember this is a base 10 log, so I don't need to write a 10, equals log of 42. Now I can use my properties of exponent, or properties of logarithms, specifically the one that says if I have an exponent here, I can move it out front. So I can rewrite this as x times the log of 6 equals the log of 42. Okay, and remember I'm trying to solve for x, and so I can divide both sides by the log of 6. So x is equal to log of 42 over log of 6. Whoops, sorry about that. Okay, and I can punch this into my calculator, and I get that it's approximately equal to 2.0860. And most of the time, I'm not sure why they like to round these to 4 decimal places. Okay, here's an example of an inequality, and we can actually do the same thing here. So I'm going to take, so I need to solve 4 to the x is less than 5 to the 2x plus 1, and so I'm going to take the log of each side. So log of 4 to the x is less than log of 5 to the 2x plus 1. Okay, I'm going to use my exponent rule. It says I can put the exponent out front. So x times the log of 4 is less than, and this exponent here, I'm going to put that in parentheses, just so I know that that's that whole thing times the log of 5. Okay, now my goal here is to get x all by itself, and that's a little crazy over here since the x is in parentheses. So what I need to do is I need to distribute on this side of the inequality. So x times the log of 4 is less than 2x times the log of 5 plus basically 1 times the log of 5. I'm going to drop that 1 in just a minute, but so basically I distributed log of 5 to 2x and to 1. Now I actually have 3 terms here: x log of 4, 2x log of 5, and another log of 5. So what I need to do is get all my x's on the same side. So I'll subtract 2x, or actually how did I do this one? I'll go ahead and subtract no, I think I'm going to keep it positive. I'm going to move this over here and move this over here. So subtracting log of 5, okay, because I want to avoid having a negative and having to flip the inequality. And then I'll subtract x log of 4. Okay. And on this side of the inequality, I'm going to leave this the same. And on this side of the inequality, I'm going to factor an x out of each term. So I'm going to take an x out of that, and that leaves me 2 log of 5 minus 1, basically, log of 4. And now to get all my x all by itself, I'll divide both sides, sorry about that, divide both sides by this parentheses. So I'm going to have negative log of 5 divided by this whole stuff in parentheses here, 2 log of 5 minus log of 4, and that is less than x. And then I can put this into my calculator. In fact, why don't we take a look at how I would do that. So I would actually use a whole lot of parentheses here. So parentheses, negative log of 5. And in my calculator, I actually have to close the parentheses on the log. Now I'm closing the parentheses on the numerator. Divided by, I'm going to put parentheses around the denominator, 2 times the log of 5, close parentheses on the log of 5, minus log of 4, and actually at the end I don't have to close my parentheses when I'm all done. Hit enter, and I get negative 0.8782. So flipping that around, x is greater than negative 0.8782. So that got a little messy, but we're basically just using the properties of logs. And I know it looks strange. It's like, what do I really mean by log 5 and what do I really mean by log 4? Don't worry too much about it. Just treat it as though it's a number, which is really what it is. Okay, and the last thing we're going to take a look at here is something that's very useful called the change of base formula. It allows you to change the base of any logarithmic expression, and ideally we want to change it to a log base 10 because I can use my calculator for that. So here's the little formula. Log base a of n equals log base b of n divided by log base b of a. Now b is your base, and that's what you can choose to be whatever you want. We're going to choose 10. So I take the base, whatever my base is here, and that becomes what I'm taking the log of on the bottom, and what I'm taking the log of here becomes what I'm taking the log of on the top. So here's an example. Let me give myself a little bit of room here. Express log base 6 of 8 in terms of common logs, and then round it to the nearest 10,000th. So log base 6 of 8 is equal to log base 10 of 8 over log base 10 of 6. So this number goes on top, my base goes on the bottom, and I'm using a base 10 log, which I could actually even write more simply as log of 8 over log of 6. Plug that into your calculator, and it's approximately 1.1606. So in this section we took a look at common logs, which are just base 10 logs, and how we can use those to solve equations and inequalities, and how a base 10 log can be very useful in changing the base of another type of logarithm.